This video concerns the Chinese postman problem. The idea, or what the problem is about, is trying to determine the minimum distance to travel through a network, making sure that every edge is travelled just once. Now, the way to do that would be via an Eulerian circuit, if that was possible. But that's not always possible. What we have to do, if it's not possible, is to kind of create an Eulerian circuit by travelling some of the edges, or by doubling up on some of the edges in the smallest possible way. What you have to do is, first of all, look at your network and decide which vertices are even and which are odd. In the case of this one here, I think we can see that there are even, and these two here are odd. So what we have to do is even them up by putting an extra edge between them. But we have to do it in the shortest possible way. It might be tempting to think, oh, from C to B we'll just double up here. But in fact, the shortest way to get from C to B here is actually via E, because that distance is just 4, whereas this one is just 2. If we're going to double up on part of the route, it may as well be the shortest bit. So what we're going to do is we're going to imagine we've got kind of double edges here. If that was the case, then all our vertices would be of even degree, and an Eulerian circuit would be possible, and that would be the shortest possible route that we could travel through all of those edges. And we've got to start and finish at A. What we're going to do is we're going to double up on this bit of our journey. So starting and finishing at A, we can go A, B, E, C, B, and then we're going to double up on this, E, C, D, E, A. That would do it. So let's double on C, E, and E, B. And our route would be A, B, E, C, B, and then our doubling bit, E, C, C, B, our doubling bit, E, C, D, E, A. Now there are other ways that you could do it, but that's the short, but as long as you've doubled on that section, you will have found the shortest route. Now I'm going to pause the tape in just a minute and come back and work out the length of those, but let's have a look at these others in first. First of all, decide on the degree of each vertex. It's got degree 3, degree 4, degree 3, degree 2. So these are our odd vertices. What we have to do is connect those or double up on those by the shortest possible route. Now the shortest way to get from B to C is going to be using this connection here, B, A to C, via that double section there. So starting at A and travelling this and this twice, we would have to go, say, AB, A again, and then CA, we've got to do the top bit yet, so we'll go C, D, B, and back to A. That's would cover it in the shortest possible distance. Double on BA, by that little 2 one, and also on AC. Okay, and the route to go would be A, B, A, C, A, C, D, B, and back to A. Well, I'll work out the distances in just a minute. And what about this one? Well, here we've actually got 4 odd vertices. So what we're going to have to do is pair them up in the shortest possible way. I think you can see if I pair these up, there's only a distance between two between those, and a distance of 2 between those. So if we pair these two together and these two together and do that section twice and also that section twice, we should have covered in the smallest possible fashion. So if we double up on BC and ED, we should be able to do it. And a suitable route would be, say, ABC, and then maybe back to B, down to E, over to D, C, round, another double section there, and back to A. That would be a good way of doing it. It'll be A, B, C, back to B, down to E, D, C, around to D, E, and back to A. Okay, I'm going to pause the tape and just work out those distances. You might like to do the same too. Okay, I got some distances worked out here, 32 kilometres, 24 and 36 kilometres. Wonder if you agree with that. I think the best thing you can do is do some Chinese postman problems from the back of the book.